Welcome to week 4 of remote learning. This week we are going to finish up conic sections, focusing on ellipses and hyperbolas. So number 1, are you up to date with remote learning? Some of you have been doing the quizzes in Canvas, but never took the Unit 14 test in GrabPoint. Some of you have done the test in GrabPoint, but haven't done the quizzes in Canvas. So please make sure that you are you're up to date. Again, as I stated earlier, we're working with conic sections again this week, focusing on ellipses and hyperbolas. Homework this week will come from sections 8.2 and 8.3 out of your textbook. And then there is a Conex quiz in Canvas. Please take note that this quiz will have some questions about circles and parabolas, but not as intense as last week, more of being able to identify which conic section it is, and maybe a little bit of completing the square if necessary. And then, as is most weeks, my office hours are 1 to 2, Monday through Friday. Please reach out to me at any time, but you can definitely get in touch with me then. And again, I'm happy to set up Google Meets. I've done that with several people last week, and it was a lot of fun being able to work some questions with you guys somewhat live. All right, let's get started. So again, I ran through these really fast. Week 1, you were supposed to have done the Unit 14 post-test and GrabPoint. Week 2, you had a vectors quiz and polar quiz in Canvas. And then last week, there was a quiz called Polar/Conex quiz in Canvas. So again, if not, get them done as soon as possible. And actually, there are a couple of you that still have not finished up your quarter 3 work, some of you that have been absent and didn't finish that test or quiz, or your grades were not passing. I've reached out to some of you. I'm going to continue to try to do that this week. Our grades are going to get locked on Wednesday. So if you have not completed your quarter 3 work to get those grades up to passing, please, please, please get in touch with me ASAP. So just a reminder, I think I had this slide last week for chapter 8 is on conic sections. And this is just a visual for how we create each of the conics. Again, last week we focused on the parabola and the circle. And so this week we are doing the ellipse and the hyperbola. And so the ellipse, a lot of kids say, hey, that's just an oval. And it does look like an oval. And then the hyperbola kind of looks like, and maybe a little hard to see here, it's kind of like 2 parabolas opening in opposite directions. So if you notice, these are pictures of what an ellipse looks like. Notice one looks longer horizontally, the other one is longer vertically. And what determines that is this top piece of information here. It tells us that a squared has to be bigger than b squared. So when the larger number is underneath the x, our longer axis is horizontal. When the longer axis is underneath the y, then the vertical axis is going to be the longer one. So if you look at these, again, we still got that HK that's representing our center. So a lot of this hopefully won't be too much of a stretch from what we worked with circles. Because an ellipse kind of looks like a circle that's just been kind of squished. Notice in both equations, they are equal to 1. These are in standard form. And then at the bottom, this is another important piece of information. It says, notice c squared equals a squared minus b squared. And no, I did not make a mistake. That is not the Pythagorean theorem, but that is a relationship. And what this relationship will be important in finding is the foci. If you remember back to our parabolas, when the absolute value of a was equal to 1 over 4c, remember c was the distance from that vertex to the focus or the vertex to the directrix. So in this case, it's going to be the same thing, the c value. This time it's going to be the distance from the center to the foci. We don't have a directrix for the ellipse, but we do have foci. And you may think I'm saying that word weird. We have 2 this time, so it's not a focus, we have foci, and there are 2 of them, and I'll show you that in later slides. So these are some properties that are important to know when working with an ellipse. That longer axis that I highlighted in yellow on the previous slide is what is called your major axis. Hopefully that makes sense because it's the longer one. The shorter axis is called the minor axis. The vertices are the endpoints of the major axis, and then they have what are called co-vertices, and those are the endpoints of the minor axis. And then I mentioned this on the previous slide, that foci, again, that's because there are two, not just one focus. They lie C units from the center, and they must lie on the major axis. So those are important properties. I would definitely jot those down. They will be helpful as we work through some examples. Again, I don't have you in front of me, so I'll probably go a lot faster since we're not in the classroom, so please pause the video as needed. So for this slide, it asks whether the ellipse will be a horizontal or vertical ellipse. That's the first question. And then the second question is, where is the center? And if you recall from the first slide with the ellipses, we said that the larger number, depending upon whether it's underneath the X or the Y, is what is going to determine if the ellipse is going to be horizontal or vertical. So in this first example, the larger number is 25, and that's underneath the X. So therefore, this is going to be, the X-axis goes horizontally, so this is going to be a horizontal ellipse. And then it asks about the center, and just like with circles, because it's in parentheses, we're doing the opposite of what we see. And so since this is a -2, the center is going to be at +2, and since that was a +5, it will be a -5. So that part is just like we did for circles. All right, for the second one, again, we're looking for the larger number. 49 is larger than 9. So once again, this one is underneath the X. And so we are going to have a horizontal ellipse, and our center, remember it's H comma K, and it's the opposite of what you would see, so that's going to be a -3. And then don't freak out. Remember, if you just have y squared, that means your y coordinate is 0. If the larger number had been underneath the y, or the y squared term, then you would have had a vertical ellipse. All right, next says, what is the length of the major axis and what are the foci? And so I'm just going to kind of teach by example. Again, the major axis is the longer one, so we know it's going to have something to do with this 25. But what we're actually doing for these, if we want to think about a quick sketch, and I do mean sketch, if we were trying to draw this out, my center would be at +2, -5. And because it's underneath the X, and we see that 25, that means that we're going to go 5 units this way and 5 units that way. And again, I won't even bother trying to draw in the ellipse, but that shows me that my major axis is going to be 10 units long. So you're essentially taking the square root, and then you are going to double that. Then to find the foci, we're going to need to use the c squared equals a squared minus b squared. I'm going to erase my horrendous picture here to give myself a little bit more room. So again, we had c squared equals a squared minus b squared. And then that should make sense why a has to be the bigger one. So 25 minus 16. And I believe that gives me 9. But that's c squared. So remember, if we would take the square root, technically we'd put plus or minus 3. but C represents the distance. And so it is 3 units from the center. And we know that our center, even though it didn't ask us, our center would be to -5, as I had done in the sketch. We said our major axis was going to be a horizontal axis since it was underneath the X. And so we would need to go 3 units to the left and the right. So again, if you think through, we're changing this X coordinate. So we're going to add or subtract 3 units along that X-axis. So my foci, if I do 2 plus 3, that's going to be 5, -5. And if I do 2 minus 3, that would give me -1, -5. Notice these are the exact same examples that we had earlier, just asking you different questions. So in the next example, it wants to know the length of that major axis. So we see the 49 is underneath the X. That means you're going to go 7 units left and 7 units right. So my major axis, so 7 times 2 would be 14 units long. And then C squared equals A squared minus B squared. So we have 49 minus 9, which is 40. And thankfully, I haven't changed my ways. I'm completely okay with just leaving it the square root of 40. I did not label the center on this one. I'll come down here and write it at the bottom. Our center would be a -3, 0. And since this was the horizontal ellipse, the foci are going to lie on the major axis. So we are going to add or subtract the square root of 40. And so our foci, we can have -3, and I'm literally just going to write plus or minus the square root of 40, 0. I didn't look at it before I started recording this, but I know I had looked at it earlier, and I think the back of the book does a lot of the coordinates like that when you're going through the practice. Just keep in mind, though, that typically they like to break down the square root of 40, but for me, I'm fine with you leaving it just square root of 40. All right, so this example is going to have us write the equation, and they give us some different information. It tells me that the width is 12 and the height is 30, and the center is the origin. So I think I'm going to start with plotting the origin just to remind myself that that's the center. And since the width is 12, that means we're going to go out 6 units this way and out 6 units this way. So we go left and right 6 units. And then the height is 30. So we're going to go up and down 15 units. And then now I can attempt to draw a picture of an ellipse. And drawing the picture is literally just to kind of help me think through. Again, the center is at the origin. So as I write my equation, it's just going to be an x squared, a y squared, and the ellipse has to be equal to 1. And this is where we're going to focus on using this 6. And this 15. And so the numbers that go under the x and y, again, left and right, is your horizontal. So that's going to go underneath your x. So that's 6, but remember it's the a squared and the b squared. So my 6 squared will be a 36. And then when I do the 15, and remember you have to square it, that 15 squared gives us the 225. So this is going to be my a squared, and this one is my b squared. So going back and using that equation from the beginning. Again, it doesn't matter. You could write the y squared term first and then the x squared. I just typically always put the x first. All right, so here the picture is already drawn for us, but once again, it wants us to write the equation. So the first thing we need to do is identify the center. And so that to me kind of looks like the outermost edge. And I think that kind of looks like the middle there as well. And so that would put my center here. So it looks like my center is -1, +2. And so I can go ahead and start that piece. Again, it's the opposite. So x plus 1 squared over, we'll fill that in a minute, plus y minus 2 squared over equals 1. And now we just need to figure out how long this major and minor axis are. So if I go from the center out to the outermost edge, I notice that that is 5 units long. And again, since that's along the x-axis, the horizontal axis, underneath the x, remember it's always squared, so that will be a 25. And then I can do the same thing for the vertical. And if I look at that, that appears to be 3 units long, but again, we are squaring. Again, that's parallel to the y-axis, but 3 squared is 9. So by looking at that picture, calculating what the center is, and then identifying the major and minor axis and looking at their length, that helps me to figure out what a squared and b squared are. Again, a squared is going to be 25 because a squared is always bigger than b squared. All right, we have another ellipse, so we're going to go through that same process. We're going to try to pinpoint where the center is. So I'm going to look, and it looks like that's kind of the outermost edge. And then if I look here, that looks like the spot. So I think that is our center. So the coordinates of that would be 3, and then we don't go up or down, so it's just 0. So we can fill in the top part. So x, again, it's the opposite, so -3 squared plus, and then it's just going to be y squared. And again, that has to equal 1. So my horizontal here is 2 units long, and we square that. That will give us a 4. And then my vertical is 7 units long, but we have to square it, so that will give me 49. And there is the equation for our ellipse. Again, this time your a squared is 49. This is a vertical ellipse. Again, the reason it's vertical, the major axis is the longer one, and this time the major axis is vertical instead of horizontal. All right, before we move on to hyperbolas, I want to review how to take an equation from general form to standard form. I know you're excited because we get to complete the square. So step 1, we want to group the x terms together, the y terms together, and move that constant over to the other side. So I'm not writing out all those steps. Again, if you have forgotten, go back and look at the week 3 video. So 9x squared plus 54x, skip some space, plus 16y squared minus 32y, skip some space, and move that 47 over so it becomes a positive 47. Remember now that we're going to have to look for GCFs. And so here, again, but we're only looking for the coefficients, the GCF of the coefficients. We don't want to factor out the x. So if we take out a 9, we're left with x squared plus, and 9 times 6 is 64, or excuse me, 54. So that becomes a 6x. Same thing here. We look at 16 and 32. Again, the coefficient of, or excuse me, the greatest common factor of the coefficients is 16. And so that turns into y squared minus 2y. And now we're going to complete the square. So we take half of 6, which is 3. We square it, which is 9. And we add it to both sides. But again, we're not really adding 9. We're adding 9 times 9, which is 81. And then for the second one, we take half of -2, which is -1. We square that, and we're adding 1. But again, we're not really adding 1, we're adding 16. So we have 9. And then if we factor that, that gives us x plus 3 squared plus 16. And that's going to give us y minus 1 squared. And then on the right-hand side, we just need to simplify 47 plus 81 plus 16, which gives us 144. But this is still not standard form because remember, an ellipse has to equal the number 1. So we have to divide everything by 144. And so essentially I'm simplifying a fraction. So 9 over 144 simplifies to 1/16. So x plus 3 squared over 16, which means that 16 over 144 would simplify to 1/9. So y minus 1 squared over 9 equals 1. So again, I told you that complete the square would come back at the end of the year. I wasn't lying. Here it is. All right, so that finishes up what I'm going to do with ellipses, and now we're going to move on to hyperbolas. All right, so hyperbolas, at first glance, you may think, wait, this looks exactly the same as the last. But remember, with ellipses, there was a plus sign in between the two terms on the left. Now we have a minus sign. And I'm going to do rough sketches of what the hyperbolas look like. You will see a much better drawn one in later slides, but these are just quick sketches. So when I worked with the ellipses, I always put the x first, but I can't do that for hyperbolas. It matters which one comes first. In the first example here on the left, we have the x coming first. So that means that hyperbola is going to open to the left and the right. So maybe something like this. Again, rough sketches. I know y'all have missed my horrible drawings. Whereas in the second example, the y comes first. So therefore, it's going to open along the y-axis. And again, it kind of looks like two parabolas opposite of one another. This time, our note at the bottom is c squared equals a squared plus b squared, which in this case is the Pythagorean theorem. And so you may think, oh my gosh, how am I going to remember which one's which? And the way I do that, if you notice for this example, for the hyperbolas in the equation, there's a minus sign for the standard form. And then, so the relationship has a plus sign, whereas for the ellipses, there's a plus sign when the equations are in standard form. And so the relationship with a squared and b squared has a minus sign. So it's the opposite of what you see. So kind of like we did with the ellipses, give you some general information. Again, there's a much better drawing of a hyperbola. Again, the x term would come first because this one is opening along the x-axis. So just like with the circles and the ellipses, your center is HK. We don't have what's called a major axis or minor axis this time. HK, it says, is the midpoint of the transverse axis. So that transverse axis is going to be the axis along which the hyperbola is going to open along. Okay, so that's my transverse axis. I'll try to highlight that here for you and use some color. So this axis would be my transverse axis. A is the distance from the center to the vertices. And so again, to kind of label some things here, when we talk about vertices, my vertices are going to be these spots. Co-vertices is kind of hard to show in this picture, but co-vertices are going to lie on the opposite axis. And then same thing that we have with the ellipses, you're going to have a foci, or you're going to have foci, so two of them, and they will be C units from the center. So again, this is just kind of general information, and then we'll get in more specifics when we work through an example. So here is a nicely drawn picture, and it says to find the foci of the hyperbola shown to the right. So I thought this was a good one to kind of go through and make some notes here. So if we look at the center, first if we look at the equation, we would see that the center is -3, +1. And then I can look at that same spot here in red and plot that point. So those are, or that is the center. Then if we want to find the vertices, if we see, and again, I'll try to color coordinate these, we have this 16 here underneath the X. And so if we look, it's going to be 4 units this way and 4 units this way. The 9 is the weird part. So when we look at that 9, it's underneath the Y, but there's not like another really part of my hyperbola. But what we do with that is, because it's a 9, that means we would go 3 units up and 3 units down. And then, hang tight, what we do now is we create a box. I think I'm going to draw the box in yellow just because I don't want it to be too much in the way. And again, this is all stuff that helps you draw the hyperbola yourself accurately. And then what we do with this box, what that helps us figure out is we don't really know, if we're trying to sketch a picture, how wide these kind of parabola pieces should be. Like, are they really skinny? Are they really wide? And what it is we take the diagonals of this box, and those are our asymptotes for the hyperbola. Again, take a deep breath. You're all good. I know this is a lot of information, but again, just trying to show you how in the world we would know how to sketch this picture. And I would have no idea how wide this hyperbola should be if I had not drawn in the block and those diagonals. So that's kind of how we find it. So going through, showing you all that work, but I still haven't even done the problem. The question asks us to find the foci. And so remember, our relationship is c squared. Since there's a minus in our equation, this is going to be a plus. Again, it really doesn't matter which one's a squared and which one's b squared, because we're just adding the two numbers together. So 16 and 9 is 25, but again, that's c squared. So c is going to be 5. And again, that's the distance, and it has to be on the transverse axis. And so we were already out 4 units, so that means this spot right here is going to be my foci. That's one of them. And this spot right here is going to be my other foci. Again, we're moving 5 units horizontally, so we're taking that center and we are adding and subtracting 5 units. So if we subtract 5 units, we would get -8, 1. And if we add 5 units, we get 2, 1. And if you look at the picture, you will see that those are the coordinates of the 2 foci that I have drawn in. Again, I went through a lot of stuff on that picture that really did not pertain to answering the question, but again, just to kind of go through and show you how we sketch a graph and what all these numbers represent on the graph. So this one, I just kind of put 2 little segments up here to represent the X and Y axis. Again, it asks us to find the foci. And so I thought I would do a quick sketch, but I'm not going to draw all the stuff I did on the previous slide. Be careful with this. Notice the Y comes first. So when I want to find the center, remember it's HK, but the H is from the X. So my center is going to be 5, -2. Some of you got tripped up on last week's quiz not paying attention to the X and the Y, and some of you would tell me the center for this one was a -2, +5. Again, the I can do a quick little sketch here. So 5, -2, so that would be my center. And then since the y comes first, I know this is going to open along the y-axis. And since I have, well, let's go ahead and just start finding our c squared. So we know c squared equals, and this is a squared plus b squared. Again, doesn't matter which one's a and which one's b. 4 plus 9, so that's 13. But that's c squared. So we take the square root. Again, no plus or minus since we're finding the distance. Again, the y comes first. So therefore, we're going to go along the y-axis. So I will go square root of 13 units up. And square root of 13 units down. And those will give me my foci. So again, that is going to this time affect the y-coordinate. And so for my foci, I'm going to have 5, -2, and then I'm just going to write plus or minus square root of 13. Feel free to write it separately, but it's not required. All right, for this example, ask us quite a few questions. Where's the center? Which way does it open? What are the vertices? And state the foci. I didn't put any piece of graph paper here. If we need to make a sketch, we can. So let's start with the center. Again, the opposite, so your HK is going to be 4, 1. Which way does it open? The X comes first. So it's going to open along the X-axis, so I call that left, right. The vertices, because it's going to open left or right. Again, reminder, the vertices, we're going to look at the 64. And we're going to think that that is 8 units. And again, it's underneath the X. So we're going to take the center, which was 4, 1. And then we're going to, since it's opening left or right, we are going to add or subtract 8 units to the X coordinate. The Y coordinate will not change. So my vertices, 4 plus 8 is going to give me 12, 1. 4 minus 8 would give me -4, 1. And then lastly, we need to find the foci. C squared equals a squared plus b squared. 64 plus 36. So that's 100. So C is 10. Again, the foci have to lie on that transverse axis. So they are going to be 10 units. And again, because this is opening left and right, it's going to affect the X coordinate. So my foci are going to be 4. And then we will need to add or subtract the square, excuse me, not the square root of 10. We'd already taken the square root. 4 plus or minus 10, 1. And then since those are whole numbers, I'll go ahead and simplify. So 14, 1. And then 4 minus 10 would give me -6, 1. So those are my foci. Again, doesn't matter which way you write it. If typically, I go ahead and simplify unless it involves radicals. So to recap, we found the center just from looking at the equation. We knew that it opened left or right because the X term comes first. We found the vertices by looking at that 64, taking the square root, and seeing that was 8, so it's going to lie 8 units away. The vertices will lie 8 units away from the center along the x-axis or the horizontal axis. And then the foci, once we find the value of C, it's that many units once again to the left and right from the center. So these are some quick ones. It's asking you to put these in standard form. Notice we have some questions here that ask us about an ellipse or a hyperbola. So the directions do tell us to divide the equations by the constant term to get it in standard form. So for this first one, I would have to divide each of these by 1600. And then if we simplify those fractions, so 16 over 1600 is going to give us 100. So that becomes x squared over 100. And then if we simplify the next one, 25 over 1600 would give us 1/64. And then that would equal 1. And then we're supposed to decide, is this an ellipse or a hyperbola? And we know the answer to that. We see there is a plus sign in the equation, so this is going to be an ellipse. For the second example, again, we'll divide everything by 225. And then we'll simplify those those fractions. So we'll have x minus 3 squared over 9 plus y plus 8 squared over 25 equals 1. And again, we know that this is an ellipse because we see the plus sign. All right, and our last example for this page, we need to divide everything by 18. So we get x minus 2 squared over 6 minus y plus 1 squared over 3 is equal to 1. And this time, since we have a minus sign, this is an example of a hyperbola. So again, for it to be in standard form, they have to be equal to 1. Okay, for this top example, since it does not tell us where the ellipse is centered, I'm just going to assume that it's centered at the origin. Since it's centered at the origin, we would have an x squared plus a y squared equals 1. And then since we have a height of 8, so that's up and down. And again, think 8 is 4 up and 4 down. So that would give us 4. And then if we square that, that would give us 16. So again, think up 4 and down 4. And then it says a width of 18, which means we would go right 9 and left 9. So underneath the x squared, we would put 81. So x squared over 81 plus y squared over 16. This next one is similar to a question we did before. First, it wants us to write the equation in standard form. So I can divide everything by 144. And then if we simplify that, we will have y plus 2 squared over 9 minus x squared over 16 equals 1. And again, this is a hyperbola, so our relationship is going to be c squared equals a squared plus b squared. So I have 9 plus 16. So c squared is 25, which gives us c is 5. Once again, remember the foci have to lie on the transverse axis. And if we now think about the center, again, pay attention to the x and y. Our center would be 0, -2. But the c value will help us locate the foci. And since they lie on the transverse axis, since the y comes first, this is going to affect the y. And so our foci, we're going to add or subtract 5 to the y-coordinate. So we're going to have 0, and if we do -2 plus 5, that will give us 3. Or if we do -2 minus 5, that gives us -7. So 2 parts to this problem. The first was writing the equation in standard form, which we have here. And then the second part was to find the foci, which are listed here. So just to kind of wrap up our study of conic sections, it says things that matter. Foci are always inside the parabola shape in a hyperbola, as well as in the parabola. When in doubt, complete the square, like if we're not sure what conic section we're dealing with. Ellipses matter which axis is bigger, so we talk about the major and the minor. Hyperbolas matter which axis, and I use quotation marks for those, comes first, so like is the x part first or the y part first. And then remember, hyperbolas and ellipses must equal 1. And so one last practice of completing the square. Again, the first thing we want to do is group your x terms together and your y terms together. Notice in this problem, the y squared is the positive and the x squared is the negative. So I'm going to start with the 25y squared minus 50y, skip some space, minus 9x squared minus 54x, skip some space, equals, and if I bring the 281 over, it will become a positive 281. Then we need to take out the GCF for the coefficients. So for the y's, that would be 25, and that would leave us with y squared minus 2y. And then for the second part of the equation, again, I'm doing the GCF of the coefficient, so I would factor out a -9, which give me x squared, and then remember a negative of a negative is a positive, so plus 6x. And then we still have our 281. And so now let's go through completing the square. For the first part, if we take half of b, so half of -2 would be -1, square it, and that would be plus 1. But remember, we're not really adding just 1. We're adding 25 times 1. So we added 25. And then for the second piece, if we take half of 6, that's 3. We square that, we get 9, but we really didn't add 9. We actually, be careful on this one, it's a -9 times a positive 9, so we subtracted 81. And so lastly, we're now going to factor. We've got our 25, y minus 1 squared, as you can tell, I really want that to be a plus sign, but it's a -9. And then we have x plus 3 squared. And then we need to simplify the right-hand side. So that would give us 225. But remember to put in standard form, hyperbolas and ellipses have to equal 1. So we've got to divide every term by 225. And then if we simplify those fractions, we have y minus 1 squared over 9 minus x plus 3 squared over 25 equals 1. And so we took that hyperbola that was in general form and changed it to standard form. So to finish us up today, I'm going to go through some shortcuts of how you can identify the type of conic section if the equation is written in general form and you don't want to go through all the completing the square to put it into standard form. So when we have a circle, the thing that you will look for is that you will have the x squared and y squared have the same coefficient. So they could both have positive 2's, they could both have negative 3's. But if the coefficients are the same, then that is a signal that you are going to have a circle. For a parabola is when you have only one square term. And it can be either the x or the y, but only one square term. For the ellipse, the x squared and y squared have the same sign, but different numbers as coefficients. And then last but not least, for the parabola, or excuse me, the hyperbola, the x squared and y squared will have opposite signs. It doesn't matter. Sometimes the values of the coefficients might be the same number but opposite signs, or they could be different, but the key is that they have opposite signs. And that wraps up for today. So your homework, section 8.2 focuses on ellipses, and I gave you an every other odd, so it's not too many. There's something about eccentricity, which I did not go over. That is for question 45, so just omit that part. And then 8.3 is your hyperbola practice. Again, I did another every other odd. Same thing, 1 through 49, every other odd, but also want you to do 51. But there are 3 questions to omit throughout that, 21, 29, and 45. And then once again, ignore that eccentricity part for number 49 for these. And then part 3, which I talked about at the very beginning today, is you're going to take the Conex quiz in Canvas. Again, just a reminder that it will cover circles, parabolas, ellipses, and hyperbolas. But I hope you guys have a great week. Again, please reach out to me. My email address is here, and I'm happy to set up Google Meets and work through anything that you are struggling with. Take care. Miss you guys.